Hey everybody, welcome back. So today we're going to be talking about graphing quadratic functions. So before we get too deep into this video, make sure you review the following. When is a quadratic function upward or downward? And remember, that comes from looking at a certain part of your quadratic function. Another thing you might want to review is how to find zeros. So go back to the zeros video, and remember there's a couple ways to do that, and that depends on the form of your quadratic function. And then 3, how to find the vertex. Now, in the past, what we did is we completed the square to find the vertex, but I'll show you an alternate method today that's a little bit faster. So let's get to it. So again, today what we're going to be looking at is how to graph a quadratic function. So given a quadratic function, we want to, or at least our main objective is to sketch. Now, keyword here is sketch. We're not going to be graphing perfect parabolas today because we are human, but we're going to sketch our quadratic functions. And what's nice is this puts together everything that we've talked about in the past couple of videos. All right, so let's start with an example. Let's let f of x be minus x squared minus 4x minus 4. Now, the first thing I recommend if you're going to sketch this graph or sketch a graph of this function, first figure out, is it upward or downward? Upward or downward? And if you observe our equation here, notice that it is a downward parabola. Okay. 2, find the zeros. Okay, finding the zeros will give you a nice point to graph, or an easier point to graph. Now, how do we find zeros? Remember, you take your quadratic equation and you set it equal to 0. Now, what I recommended in my previous video is that if you can, try to factor. Factoring is the most efficient way of finding zeros. However, if you can't factor, then go ahead and use quadratic formula. Okay. So I'm going to go ahead and factor this because I think it does factor nicely. So notice all terms have a negative sign, so let's factor that out. And then now these 3 terms, they factor into, x plus 2 squared. Okay. Now, by the way, and I know you can't see this, what I'm doing in my head when I'm factoring, I'm doing the old school guess and check method. I know there's this magic X business and things like that, but I'm old school. So I'm just doing a guess and check in my head for this. Okay. So now that we have this, though, remember zero product property. This says that in this case, we only have one or the same factor repeated twice. This means that x plus 2 is 0. And solving for x, we get x is equal to minus 2. So our only 0 of this quadratic equation is at minus 2, which means our graph should hit the x-axis at that point. All right, 3. Find the vertex. Okay, so I'm going to show you 2 ways. We're going to start with the more complex way, completing the square, which I think is a good thing to review anyway. Okay. Oops. All right, so remember in completing the square, our first step is to get a 1 in front of the x squared term. So I'm going to factor out my negative sign like I did before out of the first 2 terms. Okay. Next step, and I'm going to do this on the side. Remember, we take our new b term, we divide it by 2, and then square that. Okay, and then we take that number and we're going to add and subtract it next to our b term. Okay, so we do plus 4 minus 4. Okay, and now the beauty of completing the square, these first 3 terms are a perfect square. And notice that they factor into what we saw before, x plus 2 squared. And don't forget, we're going to drop that minus 4 down. Drop the other minus 4 down as well. And then lastly, remember, you just distribute your whatever thing you factored out in the beginning to all your terms and combine like terms. So if I distribute this minus sign, we're going to get minus x plus 2 squared plus 4. And then don't forget about this minus 4 at the end. And then what you get here is minus x plus 2 squared. The 4's cancel out. So notice we didn't really need to complete the square in this case, but I felt it was good to review it anyway. But in any case, we've completed the square. And notice our vertex is now -2, comma, 0. Okay, so -2 coming from this part here. And then secretly, we have a plus 0 on the outside there. And that gives us our y coordinate. All right, now that we have all this information, we graph. Let's pretend like those are perfect x and y axes. Okay, so usually what I do is I start by graphing the zeros. Okay, so at x equal to -2. So again, remember that means that our graph should hit the x-axis at -2 here. Okay. Now in this case, notice that our vertex is actually the same as our 0. So usually what we'd have is a couple more points here, but in this case, since our vertex and our zeros are the same thing, we only have 1 point. So to complete this picture, we're gonna have to use our imagination just a little bit. Remember, we have a downward facing parabola, so I'm gonna complete this picture by, well, putting that downward facing parabola. Okay. And then there's a perfectly good sketch of our parabola. Now, if you're not comfortable with just graphing like this, you could plug in more x values and get more points on the parabola. That's also possible. For instance, if we plug in, I don't know, let's plug in 1, because that should be a nice number. We'll get -1, -4, -4, which is -9. So we know that the point 1, comma, -9 is on our graph. So I'm going to make this a little bit more precise. So here's 1, and let's pretend 9 is all the way down here. And so we get this parabola that looks like this. The more points you have, the better the sketch is going to be. But in any case, here's a sketch. If you follow these, you should be good to go, or these steps, you should be good to go. Let's look at another example. F of x is equal to 2x squared plus 3x minus 5. So again, we're going to still do the same procedure. Okay, notice this is an upward parabola. Okay, 2, let's find the zeros. Take your function, set it equal to 0. Okay. And now just to show you guys we can do this, I am going to use the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac. 4 times 5 is 20 times 2 is 40, so that'll be a plus 40 all over 2a. Okay, let's simplify this as much as possible. So we get -3 plus or minus the square root of 49. Ooh, that's nice. So this is -3 plus or minus 7 over 4, which gives us -3 plus 7 over 4, which is 4 over 4, which is 1, and -3 minus 7 over 4, which is -10 over 4. And let's see, -10 over 4 is -2.5. All right, so we got our 2 zeros here. Or we got 2 zeros in this case. All right, and our last step, before we put everything together in sketch, we're going to find the vertex. And again, I promised an alternate way of finding the vertex, and I'm going to show you it right now. So in the above problem, we completed the square, right? But again, that takes some time, and it's not the most efficient sometimes. But another way we can find the vertex is by using the vertex formula, which is given by the following. Okay, so the vertex of a parabola is always given by -b over 2a, that's your x coordinate. And then to find your y coordinate, you just plug -b over 2a into your function. Okay. Now, where is this formula coming from? This is actually coming from completing the square. If you were to complete the square on an arbitrary ax squared plus bx plus c, this would be your coordinates here. Okay? So it is coming from completing the square, except we're not doing all the heavy lifting. Okay, so our vertex in this case, let's go ahead and figure out what our b and our a are again. So our b is 3, our a is 2. So our vertex would be at, and I already forgot, b is 3, a is 2, there we go. B is 3, a is 2. Okay, so -3/4, f of -3/4. Okay, so let's plug -3/4 into our function. And again, I'm going to do this on the side. So f of -3/4 is 2 times -3/4 squared plus 3 times -3/4 minus 5, which is 2 times 9/16 minus 9/4 minus 5. Now remember, for fractions, we need to get the same denominator here. And notice 16 is going to be probably the most efficient thing to get. So let's see. So we're going to have 18/16, because 2 times 9 is 18, minus, okay, if we want this to be a 4, we'll have to multiply the top by 4 as well. I'm sorry, if we want this to be a 16, we have to multiply top and bottom by 4. Minus, ooh, big one. All right, so 5 times 16 is, let's see, 50 plus 30 is 80. So what do we get in the end? 18 minus 36, which is minus 18, minus 80. So we get minus 98/16. Let me bust out a calculator really quick. What is... So -98/16 is about minus 6.125. Okay. So -3/4, -6.125. All right, so let's put all of this together. And again, let's pretend like this is a good x and y axis. Okay. So let's start by graphing our zeros. So our zeros we got were 1 and -2.5. Okay, so let's say this is 1, -1, -2. Let's say that's -3. So right there, smack dab in the middle. And then our vertex is at -3/4, -6.125. Okay, so -3/4 is about right here. And then let's say -6.125, -1, -2, -3, -4, -5, -6. So let's say it's about right here-ish. Okay, and then remember, we have an upward facing parabola, which if you look at our points, that definitely looks like that's what we're getting. Ooh, let's redo that. Okay, that side was a little bit better. And there we go. We have a perfectly good sketch of our quadratic function there. So again, remember the steps for graphing a quadratic function. First, figure out, do you have an upward facing parabola or a downward facing parabola? Okay, and remember that comes from looking at a coefficient of our quadratic function. 2, find the zeros. That'll give you hopefully some easy points to graph. And then 3, find the vertex, which remember there's 2 ways to do it. There's either completing the square, or now you can use this nifty, more efficient formula for finding the vertex as well. Okay. Again, this might be a little bit more computationally time-consuming, but it does work. Okay, and it could be a little bit faster depending on what your B's and A's are. Okay, and then once you find all those 3 things, sketch your graph. And again, remember keyword there, sketch.